Welcome back, guys. Today we're going to be discussing about stereochemistry. Now, let's take a look at stereoisomers. So what are stereoisomers? Stereoisomers are isomers that contain the same molecular formula or the same composition but different in their conic activity or different in their way of arrangement. Okay, so now let's talk about this structure. First of all, we have two types of stereoisomers. They are the enantiomers and the diastereomers. Now, what are diastereomers? Let's take a look at diastereomers. Diastereomers are compounds that are non-images of itself or non-images of each other, and also they are superimposable. So now, once a compound is superimposable, it is non-chiral. So all diastereomers are non-chiral carbons. Now, what are enantiomers? Enantiomers are compounds that are mirror images of itself, but they are non-superimposable. So therefore, it is, or they are chiral compounds. So now, once a compound is a mirror image of itself, it is non-superimposable. It is a chiral compound. So all enantiomers are chiral compounds. So let's take a look at this compound. Then strictly we're going to be discussing about how to name the S or R configuration. Now, this is one bromo, one chloro, ethane. So for those that doesn't know how to name organic compound yet, so I'm gonna do a video for you all that will show you how to name compound without any stress. Okay, so now let's continue. So now how to get the S or R configuration. First of all, enantiomers is an example. Let's take a look at this image for discussing about enantiomers. This is a compound. Now, if we put a mirror here, it displays this opposite of itself. Displays this. So enantiomers is saying that once it displays itself, it cannot overlap. It cannot overlap. If you place it on itself, it does not superimpose. So now we have this carbon to have hydrogen, bromine, chlorine, then a methyl group here. Then we have it to contain same thing, hydrogen, bromine, chlorine, then a methyl group. So now, but there's a difference in the way of arrangement. So now, if we are to bring this, pull out this thing here, then place it here, it won't work. If you twist it another way, place this place and this place, this one here, this chlorine will be touching this hydrogen, so it won't work. So that is what enantiomers are talking about, that they are non-superimposable. Now let's take a look at an example. Our 5 hands. Now this is a mirror image of this. So if you place this on a mirror, you have this. When you place it on a mirror, this is what it gives you. So now this is what enantiomers are talking about. So if you place it at the front of it, it does not overlap. So this is what enantiomers is talking about. There, your 5 fingers is a very short example for talking about or discussing about enantiomers. So now let's talk about how to name the S or R configuration. S or R configuration, how do you name it? We'll first of all look at the priority. So what are we talking about on priority? The highest atomic number. So the carbon that is containing 4 different elements for 4 different groups, the highest atomic number is what is named first, what is numbered first, then before to the lowest. So now we have this bromine, bromine, chlorine, carbon, then hydrogen. Which of these has the highest atomic number? It is bromine. So name bromine to be 1. Then between chlorine, carbon, and hydrogen, which of these has the highest? We have chlorine. so chlorine to be 2. Then between carbon and hydrogen, hydrogen is always 1, so surely carbon should be bigger than hydrogen, so we have it to be 3. Then we have here to be 4. So now, how do we know if this is an S configuration or an arrow configuration? Now, S configuration are mainly for anti-clockwise movement. So now, if we have this to be like this is 1, so we move from the lowest to the highest, so we have it to be like this. Have it to be like this. So it is 1, 2, 3, 4. So if it's having an anti-clockwise movement, it is an S configurated compound. So we have this carbon to be S. So now let's take a look at this display here. So we have here bromine to be the highest, so we have it to be 1, then 2, 3, and 4. So we have it to be like this. Have it to be like this. So now I said if the direction is anti-clockwise, it is S. So therefore, if it is clockwise, it is arrow. So we have S to be the left turn, then the arrow to be the right turn. The right turn. So now this is an arrow configured carbon. Let's take a look at this other one. You can pause the video, then answer this yourself. Okay. So now, between oxygen, bromine, hydrogen, and carbon, which of these has the highest atomic number? It should be bromine. So we have it to be 1. Then between oxygen, carbon, hydrogen, the highest between the two of them should be oxygen, because in the periodic table, carbon comes before oxygen. So we have it to be 2. Then we have here to be 3. Then here always be 4, because hydrogen is the lowest or the least among all elements in the periodic table. So we have our direction to be like this. So now if it is clockwise, it is an arrow configured carbon. Then this to have 1, 2, 3, 4. So we have it to be like this. So this should be an S configured carbon. Now we're gonna be discussing about chirality. Now, what is a chiral compound? A chiral compound or carbon are carbon that contains 4 different groups on it. So now, if a carbon contains 4 different groups on it, it is said to be chiral. So therefore, I just said that all chiral carbon are enantiomers. So therefore, once you see a compound that has 4 different groups on it, once you see a carbon that contains 4 different group or elements on it, it is said to be an enantiomer, which is also a chiral carbon. So therefore, it is non-superimposable. So take note of those 3 words. So now this is a chiral carbon, because this carbon is containing a chlorine, a methyl, and hydrogen, then a bromine. Same goes to this and also this. So all enantiomers are chiral compound, or all carbon having different groups here, they are all chiral carbons. So now let's take a look at some structures to name under chirality.